and welcome back to another video. Today we'll be trying to find out the area of the sector area of the sector of a circle. And we'll be doing that very intuitively, so it's going to be a very easy explanation of what we'll be doing today. So if we are trying to find the area of a sector of a circle, the first thing that we need is a circle. So let's just get that done with. Now, we'll be trying out different ways of getting to the area of a circle. So let's just take the easy ones. So let's say this is the radius of a circle and I want to find out the area of this sector such that this is a right angle. So this is pi by 2, right? This is pi by 2. Let me just zoom that in right now so that you can see what I'm doing. This is pi by 2. Now, I know that the complete area of a circle is pi r square, right? So if the entire area of a circle is pi r square, then I should be able to say that the area of this circle, if I mark it with blue, then the area of this circle should be 1/4 of the total area, because this entire circle is 2 pi, that is 360 degree. So if I'm talking about just 1/4 of 2 pi, because pi by 2 is 1/4 of 2 pi, right? If I write it this way, 2 pi is equal to 1/4. Sorry, let me write it like this. 1/4 of 2 pi is equal to pi by 2, right? So 2 and 4 can get reduced to half, and so we get 1/4 of 2 pi is pi by 2. So if I'm talking about 1/4 of a pizza, that is 1/4 of a pizza, I can say that the area of this circle will be pi r square, 1/4 of that, so pi r square by 4. So that is the area of this sector of the circle, that is 1/4 of the sector, 1/4 of the entire circle. That is 1. Now I can repeat this exercise with another sector of a circle. Let me take this sector this time. So let's say I'm talking about a sector which is actually half of the circle. So let me take a different color for distinguishing the two concepts. Uh, Now let me take green, though please don't get confused with this green. So let's say now I want to measure the area of this sector of a circle. So this is actually half of a circle. If that is half of the circle, who can tell me what will be the angle subtended for this sector of a circle? If your answer is pi, then you're correct. Because if this is pi by 2, this is actually double of the sector that we considered before. So this angle will be pi, which is also half of the entire circle's angle, that is 2 pi. So this entire portion is 2 pi. So half of that is pi. Again, we can write uh, half of 2 pi as pi, right? 2 and 2 can get cancelled, and I can write pi as half of 2 pi. So that is essentially half of the circle that we are considering, half of the angle subtended at the center of a circle that we are considering. So again, if the entire area of a circle is pi r square, then half of the circle will be pi r square by 2. So that's pi r square by 2. So what we note is that if the sector that we are considering is 1/4 of the entire circle, then its area is pi r square by 4. If the sector that we are considering is half of the circle that we are considering, then it's pi r square by 2. So whatever be the part of the sector that we are considering, whatever part the sector constitutes with respect to the circle, that number goes on the denominator, right? And this will be pi r square, and the area of the circle, pi r square, which we are well aware of, stays in the numerator. So the next thing that we'll be doing is we'll try to repeat this exercise for a sector of a circle which we are not acclimatized with. So let me try to remove these things if I can. Can I though? Let me try this, and let me try this, and let me try this, and let me try this. Yeah, that works. So now I'll be taking the color red so that again we can distinguish things from the previous exercises. Let me draw a sector of a circle which we haven't discussed before. So let's say this is the sector that we're considering. So let's say this angle is theta, right? This angle is theta. We're calling this angle theta, and we want to find out the area of the sector that I am marking over here. So this is the sector that this time I want to think of. Now let's say I can think of in such pie pieces, right? I can consider this sector to be a pie piece. If this entire is a pie or a pizza, if that is what you like, then this can be thought of as a piece of a pie or a piece of a pizza. And let's say you can have this pie piece or this pizza piece distributed, the same size will be distributed among 9 or 8 friends. So I can have, let's say, n number of such pieces. So we can have n pieces, each of which will have an angle theta subtended at its center. Now we know that the entire angle can be measured up to 2 pi, right? So this entire is 2 pi. And I am saying that there are n such theta pieces that constitute 2 pi. So I can write n theta is equal to 2 pi, right? So essentially, theta n is equal to 2 pi by theta. Now this essentially gives me the fraction that this pi constitutes of, right? So if I'm talking about the pi piece that I have considered over here, initially when I was talking about the 1/4 of the circle, I had determined that it will be 1/4 of the entire, let's say, the entire circle. When I was talking about half of the circle, when I was talking about essentially a semicircle, I had determined that it will be half of the entire circle. This time I say that this n essentially it's 1 by nth, right? If there are n pieces, n such theta angled pieces, then each piece is actually 1 nth or 1 by n. That is 1 nth of a entire pizza piece, or of an entire pizza or an entire pie. So now I can write n as 2 pi by theta. Now I'll be repeating the exercise that I did before. So what will it be? Pi r square divided by the proportion or the part that I'm considering. So for this pi piece, I'll have pi r square by, so for the previous part when we were talking about 1/4 of the pizza or 1/4 of the circle, I had put 4 here. When we were talking about a semicircle, I had put 2 here. So when I'm talking about a quarter, when I'm talking about a pi piece, which is 1 nth of the entire circle, then I'll be talking about n on the denominator, right? If I do that, I'll be getting pi r square by, I can replace n with 2 pi by theta. So I can do that, 2 pi by theta. Now theta is on the denominator, so I can write it as pi r square by 2 theta that remains in the denominator, and I can pull theta up into the numerator, right? I can do that. What I'm doing is, if I change my color, if I change the color of my pen, bring it to a beautiful purple, I am bringing this theta up. So I can bring the theta up because it's in the denominator, and then I get pi r square by 2 pi. Theta is brought up, so I get theta in the numerator. If I simplify that, I get, what I can do again is I can cancel out pi and pi from this side. So what I'm left with is, if I simplify it, I can get r square theta by 2. So that gives me r square theta by 2, right? That is essentially the area of this piece that I'm talking about, this pizza p. So this pi p's that I'm talking about, this is the expression of the area of the sector that I've considered. So this is the area. Now, if you know this expression, there is this other expression that we know. If I use a different color, let's say green, we know S equal to r theta, right? If you don't know, I'll just go over it in brief. Let's say you have an angle theta over here. Let's say this is the radius of a circle, so that's r. And if this length if this length of the circumference, which is called the arc of the circle, if the length of this arc is s, then we have this expression s equal to r theta, right? And note that in this case r needs to be in radians. So the symbol of radian sometimes uses c. So if you're not comfortable with it, let me just write that down for you. R needs to be measured in radian units. So you cannot, this expression will not hold or properly work if you are talking about r in degree forms, which is why I started this entire exercise in terms of radians. So like 2 pi, pi by 2, everything that concerns radians, not degrees. You can repeat this exercise for degrees. In that case, you will have to stop over here. You won't be able to take it further. But if you're talking about radian units, what I can do is this r square theta by 2, I can write it as follows. So r times r theta by 2, right? R square, so I can split that up. And this r theta, I can bring it from above. So if I use a different color, this r theta can be replaced with this r theta. So I don't remember the color. Yeah, maybe this one. So this is too light. Let me just get a darker color. So if I do that, if I replace this r theta with this s, I get r s by 2, right? So this is one expression for representing the area of the sector of a circle, and this is another expression for representing the area of the sector of a circle, and that is how you find that out.